the domain of a function is the set of all acceptable inputs. So sometimes you may have functions whereby you cannot plug in some values. Only certain values are acceptable. Now, those values that are acceptable are what we call the domain. Now, the range is the set of resulting outputs. So when you plug in those acceptable inputs, the resulting outputs are what we call the range. Now, for example, given the rule f of x is equals to 3x plus 2, and the domain is these discrete values, negative 1, 0, 1, and 2, we can be able to find the outputs, which is basically the range. Now, so let's work out the outputs when these numbers are plugged into this function. So when you plug in negative 1, the answer will be 3 multiplied by negative 1 plus 2, which will be equal to negative 1. If you plug in 0, that will be 3 multiplied by 0 plus 2, which will be equal to 2. When you plug in 1, that will be 3 multiplied by 1 plus 2, which will be equal to 5. And when you plug in 2, that will be 3 multiplied by 2 plus 2, which will be equal to 8. So therefore, the range is these values. These are the outputs. Yeah. So we say, hence the range is, and we list them, negative 1, 2, 5, and 8. And this corresponds to those inputs. You plug in those, which represent the domain, and then you get the range, which are the resulting outputs. So it's more common for a function to be defined over a continuous interval rather than just a set of discrete values. So for example, in this case here, we have this function, f of x is equal to 4x plus 7. Now we know that this is a straight line or a linear function, but suppose it's defined over just a set of values. So for example, negative 2 to 5. Yeah, so this straight line exists between negative 2 and 5. It's a continuous line, but it exists between negative 5. Find the range of this function. So what we can do is, since it's a linear function, we can use the endpoints to find the range. So since it is a linear function, we can use the endpoints to find the range. So basically, the endpoints are negative 2 and 5. So we want to find the value of this function when x is equals to negative 2 and when x is equals to 5. So when x is equals to negative 2, we have 4 multiplied by negative 2 minus 7, which will be equal to negative 15. And when x is 5, we have 4 multiplied by 5 minus 7, which will be equal to 13. So basically, the range will be negative 15, and that's inclusive. And these are the outputs up to 13, which is not inclusive from this domain here. And that will be our range. All right, let's look at more examples. Like I said previously, is that in some functions, you can only plug in specific values. Yeah. And those are the values that will be the acceptable inputs. And which means if there are some acceptable inputs, then that implies that there are certain values that won't be acceptable, which means they have to be excluded in that function. So let's look at the first question here, 1a. We have a square root function. So we know that we cannot find a square root of a negative number. So negative numbers basically will be excluded. Yeah, for this function here, you can only plug in positive values, including 0. So we know that the acceptable values here will be all positive values, including 0, which means the values that have to be excluded will be any negative value. So any value that's less than 0. That's basically what's required here. Again, here we can plug in only positive values. So the acceptables here, the acceptable values will be now what is under the square root here is x plus 1. And what you're saying here is that anything that can be plugged in under that square root sign has to be greater than or equal to 0, which means x plus 1 has to be greater than or equal to 0. That implies that if you just solve this inequality, that means x has to be greater than or equal to negative 1. So which means what has to be excluded will be any value that's less than negative 1. So any value that's less than negative 1 must be excluded for this function here. In this case here, we know that division by 0 doesn't work. Yeah, so division by 0 does not work. So what does it mean for this question? It means that that guy in the denominator cannot be equal to 0. So it means x plus 1 cannot be equal to 0. Now, if we just think about this as an equation and you're solving for x, so that means if you bring 1 here, you'll have x cannot be equal to negative 1. That's basically what has to be excluded, because when x is equal to negative 1, you'll end up dividing by 0, and therefore that will be a disaster. The same thing happens here. Okay. 2x plus 1 cannot be equal to 0, which implies that 2x cannot be equal to negative 1. Just solving here, so which means x cannot be equal to negative a half. If you just solve this as an equation, you end up with that. And that is the value that has to be excluded. All right, number 2. So suppose the domain is given by that, find the range for the following functions. So these are discrete values, which means the range will also be discrete values. So we need to find those outputs. So f of 1 will be equal to 1 minus 2 squared, which means the value of the function when x equals to 1, which will be equal to 1. And here, if you plug in 2, have 2 minus 2 squared, which will be equal to 0. If you plug in 3, 3 minus 2 squared, which will be equal to 1. If you plug in 4, you have 4 minus 2 squared, which will be equal to 4. So basically, we can see that the range is these values here. So we have 0, 1, and 4. In this case here, we can basically just apply the same approach and find those outputs. And therefore, we can clearly see here that the range is, and we can just list these values, 1, we have a half, we have a third, and we have a quarter.